Welcome to Math 7, Chapter 8.6 lesson on the Pythagorean Theorem. Pythagorean Theorem is based on the work of a mathematician by the name of Pythagoras, who discovered and worked out the fact that there is a relationship between the lengths of the legs and the lengths of the hypotenuse. Now, the legs of a right triangle, and this only works for right triangles, are the shortest two sides. The hypotenuse is the side that is always opposite the right angle, and it is always the longest side as well. Now, here's my right angle. That's the side that's opposite, so that is the hypotenuse. The sides that make up the right angle are the legs. So a right triangle has two legs and a hypotenuse. The theorem actually shows how the legs, and the hypotenuse are related. Here's the statement. In any right triangle, the sum of the squares of the lengths of the legs is equal to the square of the hypotenuse. All right, hit pause, take a good look at that. It may seem confusing, but perhaps once you see it put in action, it will start to make sense to you. Generally speaking, there are different ways that they write the Pythagorean theorem, but most often you will see it as a squared plus b squared equals c squared. If you have a right triangle, which I've pictured here, remember that the sides that make up the right angle are the legs. One is designated as A, one is designated as B. Doesn't matter. It's up to you. The side that is opposite the right angle and the longest side of the triangle is designated as C. Let's take a look at how it works when it is in action. Just as with you working with a formula, we are first going to write the theorem. A squared plus b squared equals c squared. It really does not matter which of the two legs we designate as A. I'm going to choose to call the 9 the A and the 12 the B. So I'm going to substitute 9 squared plus 12 squared equals, there's that right angle, side opposite is c squared. That's my variable that I do not know. Now I'm going to do the math. 9 squared is 81, 12 squared is 144. That's going to equal c squared. In the next step, I'm going to use the reflexive principle and bring the c squared to my left. Now I need to add the 144 and the 81. That will give me 225. I want c, not c squared. C is going to equal the square root of 225. If you don't know that one from your list of perfect squares, or you can use your list of perfect squares, you can also use your calculator. I believe on one type of calculator you have to press the square root key and then the 225. On the other type of calculator that some of you have, you'll have to put in the 225 and then press your square root key. Try it out. You should get 15 feet. Well, why isn't the answer squared? Because it's a length, it's a distance. I don't talk about the distance across the room as being 32 feet squared. I talk about the distance across the room as 32 feet. Example B, you hit pause, you work through it, and then I will put up the solution. Here's the solution to example B. Again, if you need to take some time to look at it, hit pause and check it against your work. Notice that I almost always choose to use my smallest leg as A. Now, notice that the sides of this triangle is 8, 15, 17. And if you'll notice, the example we had in A was a 9, 12, 15. 9, 12, 15 is based on a ratio of 3, 4, 5. These are what we call Pythagorean triples. Three, 4, 5, and 8, 15, 17 is a fairly common ratio. So is a 7, 24, 25. Now, this 3, 4, 5 Pythagorean triple, they use on a lot of math tests, like on math triathlons and so on. You can also have any multiple of these numbers. So you can have a 6, 8, 10. You can have a 9, 12, 15, like we did before. For the 8, 15, 17, you could have a 16, 30, 34. You could have an 80, 150, 170. 7, 24, 25, you'll have a 14, 48, 50. Again, the 3, 4, 5 is very common, and I have a tendency to look for it so that I can kind of help myself with the math. Now, not necessarily hard, but it does take a little time to go through all the steps. And again, please be careful to go through the steps as I have shown you. What happens, though, if I need to find the length of a leg? I can use the Pythagorean theorem. Now, here's where I kind of differ from the book. I let the unknown length be A. Even if the book says find B, I just make it A, because I like having my variable that I'm not trying to, that I have to find on my left. And I'll show you what I mean. Let's say we have, well, first of all, we'll put down the theorem. A squared plus B squared equals C squared. Now here again, remember, this is C. I'm going to let this side be A, and I'm going to say, I don't know what it is. That means the 7 is going to be B, so I'm going to put 7 squared. This time I know C, so that's going to be 25, and I have to square it. I'm going to simplify my 7 squared as 49, my 25 squared as 625. Now take a good look at what you have. You have an equation here. You have a regular addition equation, except that instead of an x, you have an a squared. Therefore, I have to subtract that constant of 49 from both sides. I need to undo it because I need to get a squared by itself. Now I have a squared is going to be 576. All right, 576. Remember, I don't want a squared, I want a. So I'm going to take the square root of 576. That one, probably not on your list of perfect squares, so use that calculator. You're going to get 24, and in this case, we have miles. And look what we have. We have the 7, 24, 25 Pythagorean triple that I just talked to you about. So, one of the ways in which we use this is going to look a little familiar. It's going to remind you of what we did with proportions when we had to find the missing length. Only, I don't have something else to compare it to. I don't have that similar polygon. I have a 25-foot wire supporting a tree that is 15 feet tall. What is the horizontal distance? Aha, you have to know what words like horizontal means. From the base of the tree out to the support wire. Now normally, you're just going to read this. So, make a diagram. Okay, I'm not the greatest artist in the world. Some of you are better, but I kind of drew a tree here. I made it 15 feet tall. I showed my wire, my support wire, going down to the ground of 25 feet. Now you have to ask yourself, what am I trying to find? Am I trying to find the leg, or am I trying to find the hypotenuse? Look for that right angle. Aha! I know it. So that's C. That means I'm trying to find the leg. I'm going to let my unknown be A and the one part I do know as a B, simply because I much prefer to have my variable on my left side. A squared plus B squared equals C squared. That's my formula. Now I substitute. A squared, I don't know it. B squared is 15. C squared is 25. Work out the squares. 15 squared is 225. 25 squared is 625. I need to solve for the a squared this is an addition equation, so I'm going to subtract. Now remember, hit pause at any time if I'm going too fast for you to keep up. Now I'm going to subtract 625 minus 225. Oh, please, I hope you don't need a calculator to tell me that that's 400. All right. Remember, I want a, not a squared. So I'm going to take the square root of 400. And hopefully you don't need a calculator there either. You can tell me that it's 20. I look at my diagram. I am measuring things in terms of feet. So it's a 20 feet. Now, look at this. It's a 15, 20, 25. That is based on the 3, the 4, the 5 Pythagorean triple. So that 3, 4, 5 Pythagorean triple shows up a lot of times. All right, that's the end today, or conclusion today, of lesson chapters 8, 6. Please respond with the word hexagon. Scouting out.